Well, sometimes I go out by myself and I look across the water.
Let's check out the voltage in this series circuit. I have a 60 volt battery and I have two resistors, a 10 ohm and a 5 ohm. And you know voltage is really just potential energy of each electron. So I like to think of electrons as leaving a battery on top of a hill. In this case, it's 60 volts. So every electron is leaving the battery on the top of a 60-foot hill, and then it loses some elevation as it passes through each resistor, and by the time it gets back home, it has dropped to the bottom of the 60-foot hill, if you want to think of it that way. So if I measure the voltages, well, here, of course, across the battery, it's 59.999. It's essentially 60 volts. And if I measure the voltages across the resistors, they also should total 60. And here I get 39.997. Essentially, it's 40. It's not exactly 40 because the wire itself has some resistance, and that's producing a voltage drop as well. But it's essentially 40 volts across this resistor. And if I measure the next resistor, it should be pretty close to 20. It is. It's 19.999. 20 plus 40 equals 60. That makes total sense. The voltage drops across the resistors must equal the voltage produced by the battery. And I can even stick in another battery. I have a 40 volt battery right here. I'll just add that to my circuit. I hope you can see that. There's my 40 volt battery. And I can check out the voltages again. So my total voltage produced, in this case, 40 plus 60 is 100. I can check out the voltages. Oops, connected that backwards. The voltage drop across this resistor is now 66.666 or 662, whatever. It's about 66.7. I bet this one's going to be 33. If I measure the voltage drop across here, it is, again, I did it backwards. It is 33.331. So 66.666, whatever, plus 33.333 is in fact 100. The voltage drop across this resistor plus the voltage drop across this resistor is equal to the total voltage produced by the sum of the voltages across the batteries. That's it.
Since I come home, well, my body's been a mess, and I miss your ginger hair and the way you like to dance.
Now let's check out the voltage in this parallel circuit. This is really even easier if you think about it. So again, voltage is really just potential energy, and I can imagine that every electron leaves this battery with 60 volts or at the top of a 60-foot hill, and by the time it gets back home, it has to lose all of that voltage, or it has to be at the bottom of that 60-foot hill. So if I just check the voltage, of course, across this battery, it tells me it's a 60-volt battery, which I guess I knew already. And now if I measure the voltage drop across this resistor, it's 59.998, essentially 60. If I measure it across this resistor, and this is a part that seems a little funny sometimes to students, it's also essentially 59.997. It's essentially a 60 volt drop going this way. Well, that should make total sense if you think about it. Again, an electron leaves the battery at the top of a 60-foot hill, let's say, and as it's moving around the circuit, it really could go either this way. In this case, it passes through this resistor before it goes back home. And so you know that it has to lose all of its voltage as it passes through this resistor. It's the only resistor it's going to pass through. So this must be a 60 volt drop if the electron goes this way. And if the electron goes this way in this outer loop, here it is going around the circuit, it must lose all 60 volts if it goes this way. So these are both 60 volt drops, and actually if I added another little branch, another little loop to my circuit, it would also be a 60 volt drop going that way. Well, that makes sense.